All right, guys, so we're going to be moving on to 3.2, which is solving systems by substitution. And this first problem, if you look at this, you may be thinking to yourself, wait a minute, I could graph that. It's already in slope intercept form. But I want to show you that you could actually use substitution to be able to do this. So what I want you to realize is right here, it says that y equals this, right? Here it also says y equals this. So you can actually use substitution even on this type of problem, which just proves that, again, there's more than one way to do mathematics any given time. But that even though this problem we may say initially, hey, that could be easy to graph, and it is easy to graph, we could also use substitution if we're more algebraic minded. A lot of people would rather just do the work, like do the algebraic work, than to try to graph it. And so what we're really saying is that y equals this particular quantity. So if y equals this particular quantity, then I could substitute this quantity in for this y right here. So in other words, if I have a problem that's like this, where both equations are in slope-intercept form, I could go ahead and just substitute this in for here, or basically another way to say that is just set these two equations equal to one another. So literally, I could do negative 3x plus 11 equals 5x plus 3. I could set them equal to each other and then just solve them algebraically. So if you're one of those people like me that likes to keep positive uh, variables, then I would add 3x to both sides. And so that would leave me with 11 on this side. I would have 5x plus 3x, which would equal 8x plus 3. And then what I would need to do here is I would need to go ahead and subtract the 3 from both sides in order to get my variable on one side by itself, which gives me 8x equals, this would cancel, 11 minus 3 would equal 8, and so x equals 1. Now, though we might think, well, we're done, we found an answer, actually all we found at this point was we found the value of x. Now remember, our system should be in ordered pair. So it not only has an x value, it should also have a y value. Well, the only thing I have to do in order to find that is to substitute this back into either one of these equations. It doesn't really matter which one. Again, just try, I guess, keep with positive values. We could put it into this first one. So I have y equals 5x plus 3. Instead of that x, I'm going to put in my 1. So y equals 5 times 1 plus 3. So y equals 8. And again, just to prove that it works both ways, I could put this 1 into here. I would get negative 3 times 1, which is negative 3. Negative 3 plus 11 equals positive 8. So either way, it still comes up to this same answer. So now I can take these two parts that I just found, and I can make that the answer, which is my ordered pair, which is 1, 8. And so 1, 8 is, in fact, my solution to this system of equations. Again, this works really well, not just in situations like this where you have both in slope-intercept form, but in situations like in number 2, when you have at least one variable already solved. So if you notice, I already have y equals 4x plus 12. So now that I know that that is the value of y, then I could substitute that value for y in for this y right here. So in other words, what I end up doing is I have negative 2x minus 2 times, instead of putting y, I'm going to put this new quantity for x and your new quantity for y, and you're going to see what happens. So instead of a y here, I'm going to say 2 times 4x plus 12, and that is still equal to 16. So it looks exactly like this equation. The only difference is I substituted this value for y in for this y right here. Now notice what happens. Now in my equation, I have nothing but x values left. So I've basically got rid of one of my variables, at least temporarily. The issue is with substitution, the reason that I don't like it as much is because now I have a lot of work to do. So now I have to take negative 2x and have to go ahead and distribute this 2 through. So negative 2 times 4x would be negative 8x. Negative 2 times 12 is negative 24, and it equals 16. Now I have to go through and collect any like terms. So I've got a negative 2x, I've got a negative 8x. So that makes negative 10x. You can already see that this is a lot more work algebraically than maybe we're used to. So go ahead and carry down our negative 24 equals 16. Now I have to add 24 to both sides. So if I add 24 to both sides, I'm going to get negative 10x equals 40. And then I divide by negative 10. And that gives me x equals negative 4. Now again, what do I have to do with that? I have one part of it, but now I have to solve for y. Well, which one of these two equations is going to be easier to solve for y? You guessed it, this one, because it's already solved for y. All I've got to do is just substitute it in. So now what I'm going to do is just take y equals 4, and instead of x, I'm going to put in my new value for x, which is negative 4. So 4 times negative 4 plus 12. 4 times negative 4 is negative 16. Negative 16 plus 12 is going to be negative 4. So I have x equals negative 4 and y equals negative 4. So my new solution is negative 4, negative 4. Okay? Now, in some situations, you're not going to have one variable that's already solved for itself, but you could get it there very easily. And I'll just look at this situation that you have right here. And actually, we're going to be doing something similar to this tomorrow when we look at elimination. We'll show you this. And these two equations, just so you know, they're both in standard form. We talked about that a little bit in chapter 2, and I had you to rearrange some terms around and find x and y intercepts. So you notice these both are in standard form. It doesn't really look like it's conducive for what we need. But if you notice, this x is kind of almost by itself. If I could get this 4y over here, then I would have it by itself and I'd be able to solve. So again, to get this over here, I'd have to subtract it. So let's just make a new equation. I'm going to put a little arrow here. So my new equation would be x equals negative 4y plus 10. And you kind of get the idea. From here, you would just take this new value for x and you would put it into this other equation. So in other words, you would put it in right over here for this x, and then we would solve. So I'll at least set it up for you, and then I'm going to let you go from there. So you would do 4, again, this 4 that's here. Instead of the x, I'm going to use this quantity here for x, which is negative 4y plus 10 minus 6y equals negative 4. And you can see already that I have nothing but y's in this equation now. Up here I have nothing but x's. Here I've got nothing but y's. So I'm going to distribute this through. Negative 16y plus 40 minus 6y equals negative 4. And I know I may be going kind of fast. And if you need to pause the video and kind of think about it a minute and write it down yourself, I would challenge you even to pause the video and try to work the rest of this out and then see if it matches up to what we're going to do. So I got negative 16y and negative 6y. Those are like terms. That means negative 22y plus 40 equals negative 4. And let's see. I'm going to have to subtract 40 from both sides. So I end up with negative 22y equals negative 44. Divide by negative 22 on both sides. And I get y equals 2 for that answer. And again, I would have to just take this y equals 2, and I could actually substitute it back in right here on this one, figure out what it is, and that will be my x value. Okay? I want to show you one more before we go today. And again, trying to get through these videos and not keep you forever. But this one's already solved for y, so it'll be pretty easy to be able to substitute that in. And again, this is kind of the ideal situation. If you've got at least one of them solved for a variable, then it's kind of easy to substitute that in. So we could substitute this value for y in right here, okay? If we do that, you're going to see here, we're going to get a special case. So I'm going to have 6x, sorry, my pencil's trying to quit, 6x plus 2. Instead of y, I'm going to use this quantity, so negative 3x plus 18, and then finish this equation out equals 36. Okay, let's take a look at this and look what happens. I've got 6x, let's bring that down, plus, and I wrote plus too fast. So here we have 2 times negative 3x. Well, that's going to be negative 6x. And then 2 times 18 is 36 equals 36. Now, I want you to just look right now at the left-hand side. Look at the left-hand side, the like terms that we have, and notice what happens. I have 6x minus 6x. What's going to happen there? Yeah, this is just going to cancel out. So this is just going to go away, and all I'm going to be left with is 36 equals 36. Let me ask you, how often does 36 equal 36? Well, 36 equals 36 all the time, right? So what this is telling us is when I get two equal amounts like this right here and it makes a true statement, then that tells me that because it's true all the time, I have an infinite number of solutions. In other words, it doesn't matter what value of x or y that I put in here, I'm going to get an infinite number of solutions. In other words, when I rearrange these terms, these two lines are going to be exactly the same. If you were to look at this graphically, you would see that these two lines lie right on top of one another. So it is an infinite number of solutions. That won't come into play as much today as it will this next lesson on 3.3, which is solving systems by elimination. But I wanted to just give you that little tidbit right now so that you already have it. If you've got any questions or concerns, obviously reach out to either me or Miss Wheeler, and we'll be glad to help you out as much as we possibly can. Thanks, and have a great day.